All right, 8th grade. Welcome to your first virtual lab. Um, we would rather be here, be able to play with the stuff together, but we're going to do this lab as a group, kind of on the video a little bit. And I'm actually, this one, even though it looks like when you first glance at it, you're going to need special equipment, I've got some instructions for you so you can recreate this at home and you can play this with your family or whoever wants to come over and help you out. So it's lab 13B, building the elements. I would normally ask you to read this through, and I think it's still a good idea. So before you actually sit down and start trying to play this game, because today your lab is essentially playing a game, you need to read through and make sure you understand the rules a little better before you start jumping in. But I'm going to go ahead and read some of the parts to you and explain what I need you to do. So lab 13B, building the elements. How were the elements created? So during the Middle Ages, people believed you could turn lead into gold if you followed the right procedures. They believed through chemistry, by mixing things together, heating them up, whatever, you could get basic stuff to become something valuable like gold. Later we learned that lead and gold are different elements with different kinds of atoms. So you can't do anything chemical to change one element to another. That's what makes them an element. You have to change the atoms inside to make lead into gold. So you have to actually adjust the nuclei of an element to make it become something else. So it says lead atoms have 82 protons, gold atoms have 79. So if I have lead and I want to make it become gold, somehow I have to make each atom lose 3 protons to get it down from 82 to 79. There's just no way to do that chemically. There are some things we can do today to, maybe have that happen. Radioactive things automatically lose some protons sometimes, and so they, could decay and maybe become gold if we're lucky. You can bombard atoms with neutrons and protons, and maybe hope that some of them hit the nucleus and stick and cause changes, but it's haphazard. We can't control it. And maybe some point in the future, if we have advanced nanotechnology, science fiction time here now, little miniature robots that can go in and actually adjust the nuclei, then maybe we can do it then, but who knows. As right now, can't happen. Moving on, part 1, building the elements. About 13 billion years ago, when the universe was much younger, the only atoms in existence were hydrogen, helium, and a small amount of lithium. These were the 3 lightest elements. Today we find carbon, oxygen, iron, even uranium atoms. Where did these heavy atoms come from? We learned this last year in 7th grade. This is all the elements were created in the super hot cores of stars. When fusion takes place, it takes light elements, forces them together, they stick together and become heavier and heavier elements. Stars get their energy by combining hydrogen atoms to make other elements such as helium. Along the way, a few protons get converted to neutrons and electrons as well. So as stars go through life cycles, they make heavier and heavier elements. Eventually, some of the biggest ones explode, and during that explosion, the temperature and the pressure help create even bigger and heavier elements. Those things get scattered throughout the universe. So today we live on a planet where there's lots of iron and uranium and things like that. So we are the beneficiaries of stars that went through their life cycle, exploded, scattered their stuff to the universe, and they collected enough together to form our planet. It's kind of cool. So today you're going to be playing with the atom game. Now you don't have these at home, so I'm going to give you some instructions to make one yourself. It's really not going to be that hard. The biggest thing you won't have are marbles, but you don't have to have marbles to play this game. Okay, so I'm going to pause the video for a minute and I'll explain what I would like you to do. All right, so here is your atom game board. All right, so we've played with this a couple times already. All right, so you know that there's a big area in the middle for the nucleus. So if you get a big piece of cardboard, big sheet of paper, a couple of them, tape them together, whatever, you can make a big board that's sort of like this. Just make yourself a big area in the middle labeled nucleus. You don't have to have all the little divots for marbles because it's unlikely you're going to have a bunch of marbles laying around anyway. So just make yourself a large space labeled nucleus. Then we've got the electron rings. We got 5 of them. 1, 2, 3, 4, 5. And remember, each ring had a certain number of divots for marbles. So as you draw these rings out, make spaces for something to go there. It's not marbles, obviously, but remember the first ring has 2 divots in it. Boom and boom. The second ring has 8 altogether. The third ring also has 8. The fourth ring has 18. And the fifth ring also has 18. And so they're kind of spaced out certain ways on this board. You don't necessarily have to mimic that exactly. There's a reason for this, which would be something you actually will learn in high school chemistry, why they are kind of grouped together here. Like in the fifth ring, we got a group of 5 here, really close together. There's a reason for that. It's nothing we're going to worry about this year, so don't worry about it. Just remember the first ring has 2. The second and third rings have 8. And the fourth and fifth rings have 18. So as you lay your board out, You make sure those spots are available for you to put something. Now, what is the something? What I recommend is you just make little pieces of counters out of paper. Get some colored paper or white paper if that's all you got. And you can have each color represent a proton, neutron, electron, much like the atom game. So if you want to keep it the way we've been doing it, then obviously you would use blue for protons, green for neutrons, and yellow for electrons. You don't have to keep that same color scheme. Just make it something that you know when you play the game. You could just keep them white and label each little piece with a P, an N, or an E for proton, neutron, and electron. That would also work. And just, when you do the game, only P's and N's can go in the middle, and only E's can go on the outside. All right? So to play this, you're going to need your board that you make, and you're going to need this version of the periodic table. This is the first version. Remember I told you the other day in my last lesson, you don't really need this periodic table anymore. Well, I kind of forgot about this. You'll need the periodic table, this one here that has the stable numbers. You'll need that one to play this game. So, I'll make a copy of that available for you again in case you forgot to take it home. So I'm going to pause the video again. We'll go back and look at the lab, and I'll explain how you play this game. All right. So, if you read this part, quick review of the atom, that kind of explains what I talked about here. There are 3 basic rules of the game. The number of protons has to match an atomic number. So when you play this game, when you put protons in the middle, it has to actually match something from the periodic table. So remember, on this periodic table, the protons, the atomic number, is the bottom number on your chart. So the total number of protons and neutrons equals a stable mass number. So if you add the number of protons and neutrons in the middle, it has to equal one of these actual numbers on the top, which are your stable mass numbers. So this example, if we're building lithium, I would have 3 protons in the middle, and I could have either 3, because 3 plus 3 is 6, or 4, 3 plus 4 is 7, neutrons in the middle to make it a legal move. And then lastly, rule 3 is the number of electrons match the number of protons. So if I have 3 protons in the middle, I have to have 3 electrons on the outside. If you recall how that would look like, I would have 2 in the first ring and my third one somewhere in the second ring. All right. You have to fill the rings going from the inside out. So if I had 10 electrons, I would have 2 in the first ring, and then the other 8 would be in the second ring. All right. Now to play this game, it's called the Game of Atomic Challenge. I will not read this part to you. You can read this yourself. All right. But essentially, what you're going to do is each person gets a certain number of marbles, and on each of their turns, they're going to put marbles or pieces of paper, since you're building this at home, on the board in such a way that you make something that's on the periodic table. All right? And so the rules are all here. There are certain things you can and can't do. All right? So when it's your turn, you'll put out, either 1 blue, 1 green, and 1 red, and 1 yellow, or 1 proton, 1 neutron, 1 electron. And as long as you can identify what you made in the periodic table, and no one who's playing with you disagrees or can call you out and prove you wrong, you have had a successful turn, and the turn goes on to the next person. And it's a game where you try to go out of marbles or counters, little pieces of paper, whatever you end up making, all right? If you can be the first person to run out of pieces, you have won the game. And there's provisions for getting more pieces in case you just don't have enough to actually make something anymore. Essentially, when you read this, you lose a turn to trade stuff in and get more stuff. So when you make your counters, when you make your protons, neutrons, electrons, make a bunch. You probably need to make 50 or more so that 2 or 3 people can play this game together, all right? So just read the instructions here very carefully. It's pretty self-explanatory. If you absolutely just have no idea, you can, text me, email me would be better, or whatever. All right. Once you get done playing the game 2 or 3 times, and you think you've got it, and okay, I get how this works now. Then you'll need to answer the part 4 questions. So really, the only thing you have to do for this lab, really, to prove that you did it, was 2 things. Take a picture of the board game you make, so I see what you ended up doing. And then answer these questions here. Questions 4A, B, C, D, and E. And that's it. That's all you have to do for this lab. It's pretty simple. It's kind of fun because you actually end up playing a game. So, make a board, make protons, neutrons, electrons, lay it out basically like the board is. If you forget what the board looks like again, there's a picture here again on your lab book. And, there's this picture here. Maybe it has not quite as good a resolution, but maybe it'll be better on your screen. So do your best. Take a picture of it. If you haven't shared your lab book with me again for 4th quarter, you need to make sure you do that. Like I did with your chapter 13 homework folder, I'm going to put the lab folder into the shared with me file that you get your test from. So you'll be able to see everyone else who's turned theirs in as well for a little while. You'll be able to see who everyone else turned in what, and this, like I'll be able to see it as well. So have fun with this. This is a Good Friday assignment. Play a few games tonight with your family, and as long as you maintain good social distancing, and you want to invite somebody over, you probably could do that as well. But just have fun with it, and just provide me some evidence that you actually did build a board and play the game and answer those questions. Have a great weekend. We'll be back for more learning on Monday.